So next up, we get to talk about discriminated unions, which sounds quite complicated and scary, but honestly, it's very straightforward. It's quite basic. It just has a very fancy name. So this is another pattern we can use to help us discriminate. Well, let's not use that term. To help us narrow types. And the core concept here is that we'll create different types that share a property in common, and that property will actually be a literal type, a literal value. So kind is not string, kind is square. Kind, it's not string, it's actually the string circle. And then we can use that. We can do a conditional, a switch statement, and TypeScript is able to figure out the type and narrow type based upon this kind property. So let's take a look at an example. We'll stick with animals again, and maybe not the most realistic, but it's also very simple to understand. So let's make some function, again called, get farm sound, farm animal sound, and it will accept some type of animal. So we'll have an interface. We can use type aliases, interfaces, it doesn't matter, but let's go with an interface called, we've got rooster, and each rooster will have a name that's a string, and maybe a weight, that's a number, and an age, that's a number. All right, and then we can have another interface for a cow that has a name that's a string. Whoops. I realize I've been very inconsistent in semicolons and commas and just relying on my auto formatter to change them over to semicolons. I apologize. I just always rely on that. I was just watching myself type right there. I was mixing commas and semicolons, and pretty bad habit, letting the editor do it for me, even though both of them are valid in an interface. Okay, anyway, tangent over. We also will have a weight for a cow, right? So that's a number, and age is a number. All right, and then one more. What other farm animal? How about a pig? Oh, I'd love a pig. I want to get a pet pig one day. I don't plan on eating it, but I would love to have a pig. They seem very cute and smart, although also I know they can bite. All right, talk show's over. Now we have these three different animal patterns, these three types, right? Rooster, cow, and pig. And this is different than what we had with cat and dog, where cat and dog had some property that was different between them, right? I used the in operator somewhere, or that was actually for movie and TV show. Here I checked to see, media is a movie or TV show. Well, we could narrow the type by checking to see if some property is in media. But what kind of sucks about this pattern is you have to know the ins and outs of every type and what they have in common and what they don't have in common. You have to know that num episodes only exists on TV show. And it's obvious here, but what if these types are really long? They're defined somewhere else in a totally separate file. They have tons of different properties. How would we necessarily know what to test for? Obviously, again, this is trivial. It's a silly example. We know num episodes is only in TV show, or duration only exists in movie. So we can do this sort of type narrowing. But imagine that we have way more complicated interfaces. Rooster, cow, and pig are defined in separate files. They have hundreds of properties. How would I know what is different and what is in common between rooster, cow, and pig? Well, right now, everything is in common. There is no difference. So how could I check to see if something is a pig, a cow, or a rooster in this farm animal sound? I really can't. Let's make a type here. We'll just call it farm animal, and it's just going to be a union type between pig and rooster and cow. All right, so then this function will accept an animal of type farm animal, just making my function definition a little bit more succinct. So I use this type alias. And then in here, animal is, of course, going to be, farm animal. It's going to be pig, rooster, or cow, but we don't know which one. And I want to know which one we're working with in this function. So this is where I could use a discriminated union. There's nothing I can test for. I can't test to see if there's, something in rooster or something in pig, because they all have the same properties. But even if they had some differences, I would have to know those differences. I would have to compare and figure out what I could test for. So the concept of a discriminated union is that we add something called a discriminant, which is just a fancy name for a property that all our types will have in common. So all the types in this union, pig, rooster, and cow. We'll have some property. We can call it kind or type. You'll see both of those in the real world. Type, you might even see this, something like that. Or what else could we do? Name. Well, we already have name, but type, name. It doesn't matter. You just want to be consistent. Some people will do it in uppercase. Let's call it kind. And then we're not going to set it to a string. We are setting it to a literal type. For rooster, we're going to have kind be rooster. And then for cow, we're going to have kind be cow. So they have this in common. That's critical. Every single one of these interfaces that we want to be able to discriminate between in a union needs to have this property in common. So kind again, and that will be pig. All right, so kind is not the name you must use, right? It could be type, kind, name, whatever you want. It just has to be consistent. And now in my code in here, I can reference animal.kind. And I can switch on that. I can do a conditional, right? This is a very simple concept. So I think the name is quite intimidating, but I think it goes without saying this is not, it's not revolutionary. It's not some, big brain idea. We just add in a label saying this is a rooster type. This is a cow type. This is a pig type or kind. So then in here, I could do maybe a switch. It's really common. So switch on animal.kind. And then we'll have a case for, what should we start with? How about pig? Okay. And then in here, TypeScript is going to know what animal is. Look at that. Animal is capital P pig. That's the type. So then in here, I'll return, oink. Alrighty. And then I can have a second case for cow is another one of our kind values. And so then in here, let's take a look at animal. TypeScript will say you're definitely dealing with a cow. But of course, up here before this switch, it's not narrowed at all. It could be any farm animal. So we'll return moo. And then let's add another case in here. Instead of just doing a catch-all at the end, let's definitely check to see for rooster, case rooster, and then animal, hopefully no surprise by now, is definitely of type rooster according to TypeScript. It's able to figure that out because we set up this property. But remember, we have to have a literal value there. We're not saying kind is just any old string. Kind must be rooster. So then in here, I'll return cock-a-doodle-doo. Not sure how you spell that, but let's say it's like that. Okay, so there we go. If I try calling this, there is one small sacrifice we have to make now, right? Every animal, every one of these types, we've got to add in this kind of repetitive kind property, but it will remind us, TypeScript tells us if we're missing it, so it's pretty hard to mess up. So now let's make a variable and try it. Let's go with my old rooster, Stevie, bless his soul, was killed by a raccoon. It was a terrible discovery. Raccoons don't kill chickens in a clean way. So he's going to be of type rooster. He'll be an object. Name is Stevie Chicks, presumed to be a hen at birth, hence the name Stevie Chicks, but then turned into a rooster. And actually did turn into a rooster. Just it's very interesting. You can read about this. Some male chickens will suppress their roosterness and then wait until they're the only rooster around, and then they turn into a rooster. But anyway, that's a bit of a distraction. And then we'll say weights. I don't know what units this is. Let's just say 2. And then age is, he lived like 1.5 years, sadly. All right, so you'll see I'm getting a warning or message. It's actually an error saying property kind is missing, but required. You have to have kind. You told me you have to have kind. So it will remind me even if I forget. And it's kind of easy to forget because it seems redundant. We're saying this is of type rooster and it has kind set to rooster. But if I set that to anything else, I'll get a complaint. Kind has to be set to rooster, the literal value rooster, if we are creating something of type rooster. And now I can call, get farm animal sound and pass through Stevie. And let's just print that out, verify the logic is working. It should be. And there we go, cock-a-doodle-doo. But the logic really isn't the point. It's more about adding in this property that is in common across our different types, and they don't have to be identical. This example it's easier to show if they look exactly the same, because then we don't have a choice. But they could have different properties as long as they have this one thing in common. It could be kind, type name, whatever you want, and then you set it equal to a literal type in that type definition. And then you can switch on it or use some sort of conditional and compare animal.kind to pig to decide if something is of type pig, or to cow. And TypeScript is able to figure out at each step along the way what our type is. It will narrow the type because we have this discriminant that we are discriminating on. Okay, so that's discriminated unions. Not too bad, just kind of a long name.